So, good afternoon, everyone. Today is the second lecture of structure analysis course, wherein we are dealing with how to solve the problems related to structures and analyze them. In previous week, we have seen multiple videos, and in the problem solving session, we try to solve the various problems related to bending moment and shear force diagram. Let me share my screen first. Then I will tell you something about what we have covered in this week. So, today is the 4th of February, and we are in the second week of the structure analysis course provided us by NPTEL, wherein me, that is Pranam Mahajan, will be your TA for this current session, and you have other two sessions also going on for the same course, wherein one session is on Saturday and another session is on Tuesday. We can look at each and every section, try to solve as many problems as possible. So let's get started. So in previous week, we have seen that how we can define the various equilibrium equations. So what are the various equilibrium equations that are available to us? So first one is we have sigma fx equal to 0. We have sigma fy equal to 0. We have moment about any section equal to 0. So these three are the fundamental equations that are required to solve any problem related to structure analysis. Using these problems, you can define the reactions that are occurring at any support in the structure. Second most, we have also seen how to determine the degree of static indeterminacy, wherein we differentiate the structure into two kinds. One is determinate structure, and second is indeterminate structure. So analysis of each of the structure, how it will be dealt, will be seen in the coming weeks, that how we are using each and every structure, whether it is determinate or indeterminate, and what kind of method we are adopting to solve that problem. So based upon that, we also discussed about the stability of the beam, that whether the beam is stable or unstable at that particular location when it is subjected to different kind of loading. Also, using the equation of equilibrium, we try to calculate the reaction forces that are occurring at different supports. So suppose we have hinge support. So how hinge support looks, this is the pictorial representation of a hinge support, in which two reactions are occurring. One is Rx and Ry. So these are the two constrained locations in a hinge support. In roller support, represented by this roller, here only the vertical direction is restrained by the roller support. Talking about fixed support, it restrains both in x and y direction, and also the moment is restrained about that particular location. So we also discussed about how the degree of freedom was defined based upon the type of support that we are using. So whether it is hinge support, so if hinge support is there, x and y direction are restrained, but the moment is free to of moment is free to provide the its subsequent values. So hinge can have degree of rotation about its rotation axis. Talking about roller, we have roller free to move about excessive and about its rotation, whereas in fits, all the three uh, supports, that is displacement as well as rotations, are restrained about that particular support. So in fixed support, we have 0 degree of freedom. In roller, we have 2 degree of freedom. In hinge, we have 1 degree of freedom. So based upon that, we also try to find out what kind of shear force and bending moment diagram are developed when it is subjected to different kind of loading. So when it is subjected to a point load, you have shear force in the form of a rectangular, a constant value. When you have a simply supported, so let's say for simply supported, your shear force diagram is linear. So this is how your shear force diagram looks. Talking about bending moment diagram, this is how the bending moment diagram looks. It has a maximum value of WL square upon 8 and have a parabolic shape. Whereas the shear force diagram has a maximum value of WL by 2 and it is linear. So if you have different kinds of loading, how it is affecting the structure, we have seen that. Now talking about this week. This week you might have seen many videos related to that, and you must have covered that various parts of truss. So what is generally a truss? So truss is a rigid structure which is composed of two force members that connect at joints and have external forces applied. So what do you mean by two force members? This force member represents that the force in the member can only be either in compression when the force is acting towards the member. Second, it is in tension when the force is acting away from the member. And third major point, you can also know that there is no bending moment in any member of the truss. This is the major difference between a beam element and a truss element. That in truss, no bending moment occurs. So how you represent? So we assume the internal forces of the truss to be put in either tension and compression, and we assume tension to be positive and compression to be negative. This is how we analyze a truss member based upon our assumptions. Also, there are certain assumptions also related to truss members. These are: first one is all joints are connected through pin supports. I don't know what's happening. Through pin supports. Second assumption is here is that loads are all concentrated. So we don't take UDL or UVL acting over the truss member. We all comment upon the concentrated load that is acting over the joints of the truss section, and they act exactly at the joints. Okay, these are the two journal assumptions that you need to remember through for any trust member. So how you analyze that? So for that, we have two methods available for solving any trust member. So one method is method of joints. So what does method of joint tells you? So method of joint is like a particle analysis wherein you use only x and y equilibrium equations. So if you have, so let's see this member. So you have this truss that is shown in this picture. So here, these are its truss members. So these are the joints. So you take any joint, determine the forces acting on member based upon the equilibrium equations available with you. That is, you use sigma fx equal to 0, sigma fy equal to 0 at any joint and solve them and try to find out the forces in the various members. This is how you use method of joints. Whereas method of sections you generally use when you have a very complex truss. So instead of determining the values at each and every joint and then locating a particular member to solve any problem, you just cut a section, you just cut any section based upon the member you require to analyze and mark the forces that are acting and try to analyze the stress. This is how I will tell you each and every method that how to solve that, and based upon that only we will continue our discussion. So in method of joint, it is more like a rigid body analysis where you can also include the moment equilibrium equation, because whenever the moment comes, so if you cut any section, all these different kinds of forces will be acting over it. So these two forces will meet at some point. If you take moment about that point, these two forces will be gone and only force you have is this. So you have only this unknown force available with you to solve and determine the value of force in that particular equation. Okay, so this is how you use method of section and method of joints. Now I also told you the two force member, so let's have a technical definition about that. So a two force member is a body that has forces and only forces, no moments. So this I have already told you, this is the basic difference between the truss member and the beam member, and it is acting on it only on two locations. So in order to have a two force member in static equilibrium, the net force at each location must be equal and opposite to each other, as well as they must be collinear. So see this member here, the tension force is acting along the longitudinal axis of the truss member. So this is the truss member, and along the longitudinal axis, the force is acting. So if one force is acting eccentric to another, then moment will be developed, and that is not required to solve any truss problem. So we require that the tension should be applied along the axis of the member so that only the axial force will be required to be calculated for a particular member. So if this body is in equilibrium, we know the two things. One is summation of forces, that is sigma fx equal to 0, sigma fy equal to 0, and second thing is summation of moment. So if you remember only these three equations, you will be able to solve each and every problem related to the truss. However, in order to have the sum of moments equal to zero, the forces must be collinear, like this thing. Like I already told you, if it is eccentric, if the force were not collinear, then the two equal and opposite forces should form a couple. This couple would exert a moment on the beam when there are no other moments to counteract that couple. Okay, so this is how you solve a problem related to a truss, and this is what is a two force member. So always remember, truss is a two force member. So these are the some common types of truss. It could be uh, Pratt truss, Hoy truss, Baltimore truss, Warren truss, and also K truss. So these are the common types of the bridge trusses we are using in our bridge construction. So one practical application that you can remember is that the truss are used in bridges. Another, you can remember that trusses are used in roofs also. So in hilly areas where snowfall is very high, so you make the roof of the structure slanting, and over the slab you put some truss kind of a structure which will uh, which will try to accommodate the load acting over it. So here also the different kinds of trusses you can remember is Hovey truss, Pratt truss, Warren truss, and Fink truss. All the four trusses differ based upon the arrangement of the diagonal members that are there in a particular truss members. So these are the some few examples of bridge trusses and roof trusses. Now, how this bridge transfers the load to the truss? So let's see that. So suppose you have a vehicle moving over this deck. So the portion over which the vehicle moves over a bridge is called as a deck. So this is the area over which the vehicle will move. Okay. So then this deck will transfer the load of the vehicle or any moving load to these stringer beams. These are the stringer beams. Okay. It will transfer the load to these stringer beams, and these stringer beams act as a transfer media. They are the transfer medium. I don't know whether you will be able to see this or not. So these act as a transfer medium to transfer the load over these beams. Okay, so it will act as a mode of transfer over these beams. These beams. So these are the beams that will take the load, and it will further transfer the load to a particular joint in the truss. So based upon the loading that is there in each member becomes either a compression member or a tension member. So designing of each and every member is done based upon the kind of load that is acting over it, and to determine the configuration of the stress. Okay, so let's get started to questions as well as the concepts that you will require to solve the problems of truss. So first question is, how many number of independent equations to be satisfied for the static equilibrium of a planar truss? So I have already told you multiple number of times you require three equilibrium equations. So these three equilibrium equations are summation of fx equal to 0. Second is summation of fy equal to 0. Third one is summation of moment about any section is equal to 0. Let me write the definition also, so that if you want to know that what are these notations, you will be able to look upon that in future. So Fy is equal to 0 tells you that the summation of all the vertical forces to be 0. Third equation tells you that summation of moments about any point to be 0. So these are the three equations that you are required to be analyzed for solving a member force in the truss. So let's comment upon the determinacy of a given truss and also the stability. For that, I will tell you the basic equation that you require for that. It is M plus R when it is less than 2G, J, then it is unstable. When M plus R is equal to 2J, the structure is stable and statically determinate. Third thing is when M plus R is greater than 2J, then it is stable and statically indeterminate. Okay, so these three equations here, M is the number of members in a truss, R is the number of unknown reactions in any truss, and J is the number of joints. Okay, but please remember, these are only the necessary conditions but not the sufficient condition. I will tell you this thing by one example, but please remember, you have to see a truss not by directly using this equation. You also need to apply your engineering sense that whenever you apply a load at a particular point, whether the truss will remain stable at that point or not. So stability you can check by your engineering sense also, but determinacy you can check directly by using these equations. So that's why these are the necessary conditions but not sufficient conditions to solve any problem. Okay, so now let's move to the question. So this is a frame truss in which A end is attached to a hinge support and B end is attached to a roller support, wherein the C also have one internal hinge in between. So how you will determine the indeterminacy in the structure? So here ds is equal to external indeterminacy plus internal indeterminacy. Okay, where external indeterminacy is given by r minus e minus R dash, where you have what is our number of unknown reactions. So here you have 2, here you have 1, so total 3. How many number of equilibrium equations you have? 3. And what is the reaction at hinge? 1. So your total external indeterminacy comes out to be -1. Talking about internal indeterminacy, it is given by m plus r minus 2j, where m number of members 1, 2, 3. So 3 members, number of reactions 3 minus 2 into number of joints 1, 2, 3, 4. 4 joints are there. Okay, so your total comes out to be 8 minus 6 minus 2. So your ds will be dse plus dsi equal to -1 minus 2, total will be -3. Therefore the structure is unstable. Okay, now next question. Here also you need to comment on the determinacy and stability of a planar stress. Here assume the diagonal members are not connected to each other. So what is the formula for ds? ds is equal to sum of external indeterminacy plus internal indeterminacy. How you solve external indeterminacy will be r minus 3. R is r minus 3 or e. So here you have 1 and 1, 2 minus 3, that comes out to be -1. Okay, now going to dsi. I have dsi equal to m plus r minus 2j. That would be, how many members are there? 1, 2, 3, 4, 5, and 1, 6. Sorry. And 1, 6. Okay, so you have 6 members here minus reactions 2 into 4, number of joints 1, 2, 3, and 1, 4. Okay, 4 joints. So your answer would be 6 minus 4, 2, 2 minus 8, minus 6. So here it would be plus, it would be 6 plus 4, 10 minus 8, it would be 2. So you can say that this truss is internally stable but externally unstable. Okay. Also, you can see if you apply any horizontal load to this truss, it will start moving in X direction. So this is the X direction. If you apply any load, suppose P load you apply in this truss will start moving. So it will not get stopped at any other point. So it means that this structure is unstable externally and internally it is stable. So let me write this point that because of if you apply any load horizontally, the truss will start moving in X direction. Okay, so it means this truss is not stable. Okay, so now let's move to next question. So solve this question. You have ds is equal to summation of external indeterminacy plus internal indeterminacy, where external indeterminacy is given by r minus 3. Solve the problem. You have two reactions here, one reaction here. So the value will be 3 minus 3. Your external indeterminacy will be 0. What about internal indeterminacy? So your DSI, how you solve that? So the formula for that is m plus r minus 2j. How many members you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 12. So total 12 members you have. And how many reactions you have? You have total 3 reactions. Minus 2 number of joints. 1, 2, 3, 4, 5, 6, 7. So 7 joints are there. So what will be the value? 15 minus 14, it comes out to be 1. So therefore the structure is statically indeterminate of degree 1. Okay, this is how you solve the problem for static indeterminacy. Now you have other concepts also. You need to define that how would be the number of zero force members in the structure. So static indeterminacy is I am covering till this part. Rest any other problem you have, you can provide us in our I think what you will call it a discussion forum in Swayam app, wherein you can post any question or query related to that and all the TAs will be able to help you regarding the solution. Okay, so let's move to zero force member. So why you require to calculate a zero force member? So suppose let's see only, I will tell you, let's see this joint only. So if you consider this joint, you have four forces acting upon at that particular joint. Okay, these are the four joints that are acting. So it means how many unknowns are there? One, two, three, four, five. But number of equations available with you are only two, because internally you can only apply sigma fx equal to 0 and sigma Fy equal to 0. Then how you will solve the problem? Maybe one or two you will get from other joints also. But what about the rest? There might remain some unknown that can't be solved at particular joint. Okay, to solve that, you first need to determine what are the zero force member in a particular truss. Then you can easily solve any problem related to a truss. So let me erase this. I will let you know how to determine the zero force members. So first take a simple problem. In this, how you will calculate? So you will take any joint. So take a joint. Suppose we will start with joint B. So if we take a joint B, okay, and assume all the forces away from the joint to be tensile, so that would be FBC, that would be FBA. Apply summation of horizontal force equal to 0. You will be having FBC equal to 0. Okay. Now use another equation. Some sigma FB equal to 0. Then you have FBA equal to 0. So this is how you will calculate zero force member in a particular truss. So your two members are already gone. Now take another joint. So we take joint E. Draw the free body diagram of this joint. Okay. So here the two forces will be FEC and FED. Yeah. Let's say this angle is theta. Okay. If you use summation of f of h equal to 0, let's start with summation of fy equal to 0. Okay. If you take summation of fv equal to 0, you will be having fec sine theta equal to 0. So this implies your fec will be equal to 0. Now, if you take summation of horizontal force equal to 0, you will be left with summation of FED plus FEC cos theta equal to 0. Now, this term is already 0. So, what will be this term? FED will also be 0. Okay. So, out of number of members, 4 forces are already gone. So you can draw this member also without considering these. So now the remaining unknowns are only 2 at this joint, 2 unknowns, 2 unknowns, and 2 unknowns. So use 2 equations at each and every joint and solve the problem easily instead of being complicated by the additional redundant forces or members that are present in the truss. Now let's move to the question. So you are provided with this question. You need to identify the zero force members and then provide the total number of zero force member that are there in this particular kind of a truss. So let's see, we will take this joint. So this joint is same as this joint that we have already seen. So here the forces will be, this will be 0 and then this will be 0. Okay. Now take the topmost part. In the topmost part, if you take this joint, the vertical force will be taken by this member Okay, and this force will be 0. So it means this member will also be 0. Okay, now go to another joint where it is perpendicular. Okay, suppose this joint. Here if you apply summation of horizontal forces, both these force and this force, you can calculate the values. The only value will be 0, will be this force. Similarly, take uh, another joint that is there in the member, this joint. Here also this member will be 0. If you go to this joint, here also this member will be 0. And finally, you have another member also that will be 0. See this. Here it will be reaction RB. Okay. So that reaction will be taken directly by this member. Then this member will be 0 force. This is how you by knowledge, or sometimes you can miss also. So it is not mandatory that you have to remove each and every 0 member before solving or analyzing any trust member or truss. So sometimes they may remain, and in the meantime, in the calculation, you came to know that these are the 0 force members. But by technical or by your mechanics knowledge also, you can remove the some members in the starting and try to solve the problem very easily. So calculate how many number of total number of 0 members are there. So 1, 2, 3, 4, 5, 6, 7. So therefore total 7 0 force members are there in this given truss. Okay, so this is how you solve that problem. Now let's move to the problem of method of joints, and I will first tell you what are the various steps that you require to solve the method of joint problem. What is method of joint? So method of joint is a form of particle analysis where after solving for the reaction forces, to solve for the unknown forces also at each joint until you have found the value of each member. So this whole definition covers the method of joint. But any problem related to that will clear all the doubts you have in that particular definition, and you will be able to solve that very easily. What are the various steps? First step is convert all the constraints into reaction forces with appropriate levels. So it means any hinge support, roller support, to provide proper reaction to them. That is RH, this would be RH, this would be RY, this would also be R, suppose BY. Okay, so you remove these reactions, make a free body diagram of the truss, apply the reaction forces. Then, first of all, using equilibrium equation, solve for reaction forces and only looking at the external forces and solve using equilibrium equation. So you have three equilibrium equations available with you: sigma fh equal to 0, sigma f v equal to 0, sigma m at any particular section equal to 0. Okay, use these three equations and solve the problem and find the reactions RH, RY, and RBY. Okay, then you pick any joint which have the least number of unknowns. Suppose this is the unknown FAB, FAC, and you have the reaction available with you, this one, RBY. So take this joint, analyze them using equations sigma of FF H equal to 0, sigma of F of V equal to 0, two equations, two unknowns, you will be able to get the value of FAB and FAC. Similarly, proceed further and try to analyze the forces at each and every member in the truss. Okay, so this is method of joints. So let's take a simple problem. We'll try to solve this and get the result out of that. First of all, make the reaction forces. This is our reaction force. This is our RAY. This is our RBY. Here there is no horizontal force, so I am not applying. Yeah, let's make it a horizontal force also. Then I will write directly RAS will be equal to 0. So use your knowledge, directly write it. Don't look that whether it is there or not. Here RAY plus RBY is equal to 50 kilonewton. Okay. Now take moment about that point. Moment about A equal to 0. Consider anti-clockwise rotation to be negative. Minus RBY into 4 plus 50 into 2, and the sum will be equal to 0. So from here you will get the value of RBY. It would be 100 by 4, it will be 25 kilonewton. Okay, this value we got. Now use RAY also. RAY will be 50 minus 25. So RAY will be 25 kilonewton. Okay, so you got the value of reactions. 25 kilonewton, 25 kilonewton. Now you need to find the force in this member. Okay, so take the joint B. So now taking joint B, taking joint B, draw free body diagram of this joint. So this is our joint. Okay, so here RBY is 25 kilonewton. This is FBA and this is FBC. So you require FBC to be calculated. Now what is this angle? So this angle is, this is 4 meter, this is 4 meter. No, each side is 4 meter. So this angle in between them will be 60. Okay. So this is 60 degree. Now use summation of vertical forces equal to 0. It will give you FBC sine 60 plus 25 equal to 0. So calculate the value of FBC. That will be minus 25 divided by root 3 by 2. So what will be the value? FBC will be equal to minus 50 by root 3. So this value tells you that the hair force will be compressive. If you want to calculate the value of FBA also, then use sigma FH equal to 0. Then what will be? It will be FBA plus FBC cos of 60 equal to 0. Okay. Put the value of FBC. It would be FBA is equal to minus 50 by root 3 into 1 by 2. So this implies FBA will be minus 25 by root 3. Okay, 5. Here also this value will be compressive. This is how you solve the values of forces at each joint. Now let's move forward. We have done this for method of joints. We will do some other problems also. So let's have a look out first with method of sections also. So what is method of sections? So the method of sections uses a rigid body analysis to solve for a particular member or two. So whenever you require to solve a problem for one member or two members inside a particular truss, you use method of sections. So here, instead of looking at a particular joint, you make a cut through the truss and then turning the internal forces in the members and applying the moment equation at a particular joint so that other unknowns will be zero on you and you will be left only with one unknown, and from that you can determine the value of force at that particular truss member. So what are the steps for that? So for that, first of all, draw the free body diagram of the truss member. Okay, first draw the free body diagram. That means you will mark the reactions at each and every support, and using equilibrium equations you will solve for the external reactions acting on the truss. So first you will find the reactions RH, RAX, RAY, RB, RBY. It could be anyone. I'm just giving you this example because in previous case also you have done like this. Then you cut the truss based upon the type of or the number or the member that you need to be calculate the value. Okay, you cut the truss and usually it is not a convention, it is I can say experience that analysts used, that they consider the smaller part of the truss to analyze the problem. Okay, but there is no hard and fast rule that you need to take only the smallest part. You can take any part and try to find out the values based upon your choice. Then draw the free body diagram of either one of the two section you have created. Write equilibrium equation for each section and solve the equilibrium equation for that unknowns. This is how you solve the problem of method of sections. Now this is a truss given to you. So here you have to determine the value in member CG and EF. So here CG is this, EF is this. So if you apply method of section, how you will be able to solve? Let's see. So first we will calculate the value of reactions. So use summation of vertical forces equal to 0. So here let me mark it. Oh, so this is RB. This would be RA. I am not taking horizontal force because I know the horizontal force will be equal to 0. Okay. So this is RA. Now summation of vertical force will be equal to 0. This implies RA plus RB will be equal to 10 plus 25 equal to 35 kilonewton. Now take moment about A equal to 0. It will give you, take anti-clockwise moment as negative and clockwise as positive. RB into 2, 4, 6, 8, 10, 12. Okay, 12 minus, now it will be plus because it is clockwise. So it will be 25 into 8 plus 10 into 4. That will be equal to 0 and it will give you the value of reaction that comes out to be 25 into a 200 plus 40 is the 240 divided by 12. So your RB will be 20 kilonewton. Okay. Now, what will be the value of RA? So RA will be equal to 35 minus 20 equal to 15 kilonewton. Okay, so your reactions are calculated. These are 15 kilonewton. It is 20 kilonewton. Now cut a section and try to analyze the problem based upon that. So I cut the section like this, and I have to find the reaction force in EF. So what I will do, I will take the upper part. So here, this will be one reaction. Mm, This will be one force, internal force that is developed. This will be another internal force that will be developed. And here the member goes like this. And then this is also another force that is developed. So now let's mark them. So this is FBD, this is FED, this is FEF. Okay, now let's determine the angles also. This angle is theta. So suppose EF is at an angle of theta. Okay, this is joint E, this is joint B. So let's calculate first the value of theta. This is theta, then this will also be theta. If this is theta, find the value of theta. So theta would be tan inverse. What is the maximum distance here? It is 10. This is 10, 2, 4, 6, 8, 10 vertical distance. So here 5, that would be tan inverse 5 by 10. Calculate the value. You will get theta equal to 26.57. Okay, so this is your theta. Theta equal to 26.57 degree. Now both of these forces will meet at a particular point, that is point D. Okay, fine, right. So I will take moment at that point now. So if I take moment at that point, both of these forces will be zero because there is no perpendicular distance available for them to act upon it. So now the only force remaining with me is that this reaction, which is RB equal to 20 kilonewton, and that force EF. Okay, so let's resolve this force. So it would be FEF cos 26.57. What is the distance between them? The distance between them is 5. Okay, so 5. It is anti-clockwise, so negative. Now take this point in vertical direction. It will provide you clockwise moment. So FEF sine 26.57 into what is the distance. So from here, the distance is 2 meter. Okay, and now another reaction RB. It is at a distance of 4 meter from point D. Okay, and providing you anti-clockwise moment, so that will be also equal to 0. Now solve for this. You will get the value of EF equal to minus 22.36 kilonewton. Okay, this is how you solve for any particular member using method of sections. This is the most easiest way. Otherwise, if you take the method of joint, you need to first calculate the value at point B, then you have to move to point E, and then you will be able to calculate the value of force EF. Another joint that we have to require is EF. EF you have already calculated. We need to calculate CG. So where is CG? So let's mark it. So this is our CG member. So I think you should be able to know by this time that if two forces are collinear with each other and any additional force, any additional member that is passing perpendicular to it will have a zero force member when no external force is applied at that particular point. So at joint G, since two forces are equal and opposite, therefore here F E C G will be equal to 0. Okay, so yeah, this is how you will do this problem. Now let's move to another problem. So this is a problem where you need to calculate the force in the member DE of the following truss. So where is the member DE? This member. So if you want to calculate the forces, you can calculate reaction force. I think there is no requirement for that, but if you want, we will do that. So here, if 15 is acting on this side, here the reaction force RAX will be equal to 15. These are the vertical forces RAY, RBY. Okay, so therefore RAY plus RBY will be equal to 10 kilonewton. Okay, now take a moment about point A. Take moment point about A, then you will be having RBY, since it is anti-clockwise and distance between them is 4. Okay, plus clockwise force by this 15 into 6, that will be equal to 0. So your value will be 15 into 6 divided by 4. So RBY comes out to be 22.5 kilonewton. Okay, therefore RAY will be equal to 10 minus 22.5 equal to minus 12.5 kilonewton. Yeah, but I don't think if you want to require solve the problem for this DE member, you require this reaction force. So directly use this point as joint E. So for joint E, draw the free body diagram. So here this force is acting like this. It is like this. Vertical force, horizontal force. Yeah. So you have this as 10 kilonewton. This has 15 kilonewton. If you take this member, it would be FED. It would be FEC. Now you require to calculate the angle. Let's calculate that. Let's say this angle is theta. That is this angle, theta. So what will be the value of theta? Let me add a slide. So theta will be tan inverse In horizontal, the distance is 4. 4 by 6, the value comes out to be 33.69 degree. So this angle is 33.69 degree. So now you have to calculate the value of ED. We directly use summation of horizontal force equal to 0. Let's use that. So summation of F of H equal to 0. You are having FED sine 33.69, and only the reaction force will be external force is 15 that is acting on it, that will be equal to 0. It will provide you FED equal to minus 27.04 kilonewton. Okay, here also the value is coming out to be negative, so it is a compressive force, not a tensile force. Another value, if you want to calculate, you can also calculate that. Use summation of F of V equal to 0, then it would be FED cos 33.69, okay, plus FEC, okay, plus 10 equal to 0. So what will be the value of FEC? It will be equal to minus 27, so it will be plus 27.04 cos 33.69 minus 10. So value of FCEC comes out to be 27.04 cos of 33.69 minus 10. So it comes out to be 12.498 kilonewton. But this time the value is positive. So it is a tensile force. So this is how you solve the problems related to trusses, either by using method of joints or by using method of sections. Let's move to another problem. So in this question, you need to calculate the value of force in member EF, like this means this force, and CD, this force. So how you will calculate? So directly first calculate the reaction force. Here since the horizontal force will be acting, so horizontal reaction will also be there. RAX, RAY, RBY. So RAX is equal to 30 kilonewton. Okay. Now use summation of vertical force will be equal to 0. This implies RAY plus RBY equal to 20. Okay. Then use moment equation, moment about point A equal to 0. This will give you minus of RBY into what is the distance? 4 plus 20 into the distance 2 plus 30. Now what is this distance? This distance you have to calculate. So this distance will be, suppose it is 60, it will also be a 60. Make a vertical line. So you require this distance. So if this is 60, this will be 30. So it means AC upon CF will be equal to tan 30. We have the value of AC. So CF will be equal to AC upon tan 30. So your CF will be equal to 2 upon 1 by root 3. So it will be 2 root 3. Okay. So this is your vertical distance, 2 root 3. So this length is 2 root 3. So multiply it by 2 root 3 and then equate that equal to 0. Find the solution. You will get RBY equal to 35.98 kilonewton. Therefore, RAY will be equal to 20 minus 35.98. That will be equal to minus 15.98 kilonewton. Yeah. So this value will be minus 15.98 and this value is 35.98. Let me write it again. 35.98. Yeah. Now if you have to find the value of EF, let's go directly to joint F. Okay. I will add one page. Yeah. So for joint F, draw the free body diagram. So this angle and this angle will be 30 degree. Here the force will be FFD. This is FFE at point F. And here external force of 30 kilonewton is also applied. Okay. Now find the values. If apply summation of vertical force equal to 0, you will be having FFE cos 30 plus FFD cos 30 equal to 0. This implies FFE is equal to minus of FFD. Okay, so one relation you got from here, one relation you will get using horizontal force also. So use summation of f of h equal to 0. That will be equal to f of fe sine 30 plus 30. It will be equal to ffd sine of 30. So you can write it as also ff you can write it as minus f of fd. So therefore you will be having 2 of fd sine 30 equal to 30. Okay, so the value of sine 30 is 1 by 2. So your final value of ffd will be directly ffd will be equal to 30 kilonewton. Yeah, this also implies your ffe will be equal to minus 30 kilonewton. Now another joint value you require is the value of CD. So for that you need to take another joint, that is joint A. So take joint A, draw the free body diagram. So this force is FAD, this is FAC, angle between them is 60 degree, you have the force equal to 15.98 kilonewton. Now let's solve. We require only FA, we require FCD, but directly we will calculate uh, FAD and then we will go directly to joint D. Okay, so use summation of vertical force equal to 0. It will give you FAD sine 60 equal to 15.98. Okay, this implies FAD equal to 18.452 kilonewton. I can calculate other force also, but I will not do because we don't require that. And I know it is too much for you at that particular time. So I will directly move to joint D. So let's move to joint D. So what are the forces that are there in joint D? So one force is this. Okay. Here, one force. And then another force is this. Another force in third direction. Yeah. These are the forces. I will make one coordinate axis also. Okay. Now let's name it. This is FDA that we have now calculated. This is FDF that we have already calculated. This is FDE that we have calculated. FDC that we need to calculate. So this value we have calculated it as 18.45 kilonewton. This value is 30 kilonewton. Now let's calculate the value of FDE. So use summation of vertical force is equal to 0. This will imply FDF. Let me mark the angles also. It will be then easy for us. This is 30, then it will be 30, then it will be 60, then it is 30 degree. Now FDF cos 30 degree will be equal to FDA sine, not sine, cos 30 degree plus FDC sine 60 degree. Okay, so FDF is 30. So what is the value of this? It will be root 3 by 2 FDA 18.45 root 3 by 2 plus FDC root 3 by 2. So all will be gone. Only value remaining is FDC will be 30 minus 18.45. So solve this via value. You will get FDC equal to 11.55 kilonewton. And this value is tensile. Okay. So this is how you will solve any problem, whether it is method of joint, method of section. Now only last problem is left for today's session. We will solve this problem using method of joint as well as with method of section. So here you need to calculate the value of member DF. So GF. So this is your member GF. And where is member of BH? So this is member of BH. So for that, let's calculate the value of reaction force first. So here the reaction force, let's say this is your our reaction force, RA and RB. And we'll resolve this force into some theta. So if this is theta, your theta will be tan inverse 3 by 4, and its value will be 36.87 degree. Okay, if this is theta, this will also be theta, then this will also be a theta marked perpendicular to that. That will be 90 minus theta. So it means this angle also will be theta. Similarly, the force is inclined at an angle of theta in both the sections. Now take moment about A equal to 0. You will get minus of RB into 16. Okay, minus of 20 cos 36.87 into 4 12 plus 40 into 8 on minus 40 into 8 minus 20 cos 36.87 into 4 equal to 0. Solve this value, you will get to know the value of reaction force RB. RB you will get as minus 36 kilonewton. Okay, I have calculated this value and I am writing that. So you please calculate, then it will be easy for you to solve any problem. So let's directly move to joint B. We will solve this by using method of joint. Okay. So this will be RB equal to minus 36 kilonewton. Here the forces are there. One is FBH, another is FBE. We require FBH to be calculated, and the angle is 36.87. So we use summation of vertical force equal to 0. This will give us FBH sine 36.87 equal to 36. Okay, by this we will get the value of FBH equal to 60 kilonewton. Another force also we can calculate, but I am not currently doing that. Now for this, to calculate EF and force in GF, use method of section. Okay, so let's divide the section first. If I divide this section, how the joint will be built. So using method of section, so yeah, these are the different forces that are acting on it. I will make also. So this will be 36 kilonewton reaction at A. You have another force FGD here. This force is FCD. This force is FGF that you need to calculate. And this is 20-degree external force that is provided to you at an angle of theta. So this is also angle theta. So this is the free body diagram. If you extend this line further, you will see that both of these are mm, meeting at a point D. So if we take moment about point D, we need to only calculate the value of FGF. That's all. So it will be calculated. It will be fine. So we'll directly calculate moment about point D equal to 0. Then we will be having FGF cos 36.87 into 3 plus FGF sine 36.87 into 4 plus the 20 kilonewton force. That is also need to be resolved into two forces. Okay, so 36.87 into 4 minus 20 sine 36.87 into 3 minus 36 into 8 equal to 0. So solve for FGF. You will get here as 2.4 FGF plus 2.4 FGF equal to the other values 260. So by that you will get FGF equal to 54.167 kilonewton. Okay, and it will be a tensile force. So this is how you solve a problem. So this problem you need to calculate the member force GF and BH. So you have calculated BH also and BH, and this is your GF. Okay. So all the problems are completed. If you have any doubts related to that, you can ask me or you can ask us in the discussion forum that is available for you. We will try to reply as much early as we can so that your query will be resolved as early as possible. So please, again, I am reminding you that we three TAs are taking the class on Saturday, Sunday, and Tuesday. So all of you can join this class and have a look upon what kind of questions we are discussing, and that will help you to solve the problems that are given to you in assignments. And I think the each and every assignment has a deadline from Sunday night. So try to solve the assignment, and if you have any doubt related to that, ask them to us or write to that discussion forum. We will try to give you answer as early as possible. So in this week, we have covered the basics about method of joints, method of sections for the truss. So for us, pertaining to the second week, I think we have covered the syllabus. Now in the next week, we will see the deflection of truss using the method of virtual work.